This is T2, day 27, minimizing costs, looking at fencing. We just have one problem to look at today. And like all the other videos and problems we've looked at, we want to decide what is it that we're minimizing, and then we'll need an equation for that. So in this problem, suppose we want to fence in exactly 2,000 square feet. So instead of maximizing the area, we're given how much area it needs to include. And that might come in a problem where, for example, if you were starting a children's center and you needed to have at least, or you had to have a specific amount of play area outside. So you need this 2,000 square feet as shown below. By the dimensions that will minimize the cost. Okay, so we're told that, or we see that we have a building along here where we're not going to need any fence. And it might be a good idea to throw some variables on here so that we can call our sides as we need them. So we know that the area is 2,000 square feet. So the area, which is x times y, is 2,000 square feet. We'll set that aside. If we're going to minimize our cost, we're going to need a cost equation. So the cost is equal to $3 per foot for y length plus $7 a foot for x length and another $3 a foot for the other side y length. So we've got 6y's plus 7x is equal to our cost. And again, we have too many variables. We know we want to be able to take a derivative. So we'll come back over to this equation and solve for y. Y equals 2,000 over x. And we'll use that up here, that the cost is equal to 6 times 2,000 over x plus 7x. Or the cost is equal to 12,000 over x plus 7x. Well, if I need to take a derivative, I don't really like having that x in the denominator. So I'm going to make that 12,000 x to the negative 1 plus 7x, so that when I go to take the derivative, I can do that more easily and have this negative 12,000 x to the minus 2 plus 7. Or if you prefer, we can do 7 minus 12,000 x to the minus 2. And from there, we're going to set that equal to 0. And we have 7 minus, let's do that as 12,000 over x squared equals 0. Or 7 equals 12,000 over x squared. 7x squared equals 12,000. So x squared equals 12,000 over 7. Take the square root of each side. We don't need to consider the negative. So the square root of 12,000 over 7, which is approximately 41.4. As always, we want to check our answer and make sure that if we're looking for a minimum, that we're getting a minimum. So these are our x values. Our key value here is this 41.4. If I look back at my equation as I have it in the box, it might be easier to look at it as c prime equals 7 minus 12,000 over x squared. If I'm looking at it in this form, I can say, well, I can't plug in a 0 for x because that's undefined, but I could plug in a 1, and then I have 7 minus 12,000. So to the left of our key value is negative. If I plug in something bigger, let's think about 100, that's going to now be a positive value. So that's decreasing, that's increasing, that's a minimum, and that's what we wanted. So our x value is equal to 41.4. Our y value, y equals 2,000 over x, y equals 2,000 over 41.4, gives us 48.3 feet. And those are both approximate. Now we want to know what is our cost. Well, we'll come back to our cost equation. The cost is going to be the 41.4 feet times $7. And 2 of those 48.3 feet times $3 gives us this, you'll find kind of curious, $289.80 plus $289.80 gives us a total cost of $579.60. And that is our minimum cost. Hope that helps.